a little bit of housekeeping to let you know that we do have a Q&A window. Please open that up and feel free to submit your questions at any point in time during today's webinar. We will answer those questions at the end. We have with us today both Larry Brody and Steve Wen. Steve is with Sony, and Steve is going to be representing as a senior solutions architect today. He'll be taking you through the presentation. Larry is with us, and he is with our media and entertainment team with Diversified in the Middle Atlantic region. So he is our VP and general manager in that region. And he'll be as well participating to help answer questions and to provide a little bit of insight from Diversified as well. Please keep in mind that your chat window is available for you. If you do have some needs, please let me know. And I'm going to go ahead and turn this over to Larry to briefly introduce himself and to introduce Steve. Thank you so much.
Hello.
All right, Larry.
You're good? Okay, great. So thanks everybody for joining us. Good day to you all. I wanted to just give you a little bit of background. I have the privilege of being the account executive for a number of different major clients, a couple of which are implementing new IP-based facilities. These are, in both these cases, the first IP facilities that these clients have implemented, and they are both pretty major facilities. One for a major television network, TV station, O&O, and another for a news organization based in Europe, but moving in force to the Washington, D.C. area with their news bureau. One of the things that's been interesting about this process is that we're sort of moving into the next generation of IP-based systems with a focus on IP live production. There certainly have been IP systems done up till now. Diversified has done any number of them. But a lot of it was done while the technology was maturing. Now we've reached a point where we've got several established SMPTE standards, which we're all designing and building to, which theoretically provide for interoperability and other new useful features for all aspects of IP. So getting these kind of things implemented and designed to scale is certainly a very challenging endeavor. And one of the great things about being here today with Sony is that Sony has spent a lot of time making those systems work and talk to each other and developing products which really are kind of at the pinnacle of that IP live production concept. So without further ado, I'm going to turn things over to Steve Wen. I will jump in as appropriate here as we move along. But Steve will give you a good rundown of IP technology in the live environment in general, and certainly how various issues and problems are solved as we design and build these systems. So Steve, take it away. I think you're muted.
Oh, perfect. Thanks. Well, thanks, Larry. Well, certainly this is a timely topic because we've seen the systems that we use to produce media change as we shift everybody to a lot more remote production, and we start leaning on networks more heavily, and we technically distance staff, and a whole bunch of things that have affected broadcast and production this year. As Larry mentioned, there's a lot of activity in systems in terms of looking ahead at what the foundational infrastructure needs to be to support the flexibility and the feature set that we need going forward. So I understand we've got a good set, quite a large number of people on the call. So in a very diverse group, a diversified group, I'll apologize to some of you for the background in the ABCs at the beginning, and I'll apologize to other of you for some nitty-gritty technical details that will probably enter the conversation. So we'll try to drive this story kind of right down the middle and spend some time first with some background about sort of the standards and the reference architectures that we depend upon to build up IP systems, and then step through sort of what are the mechanics of getting our SDI components and subsystems onto an IP network and make them do what SDI does for us, but also be able to take advantage of what IP does for us. How we knit those things together, and then after they're on a network, then how do we manage those as we move away from the appliance sort of nature of SDI into IP. And then at the end, we have a case study that it was quite interesting and fun to work on with Diversified for a sample customer who went down that path of, is it time to go into IP or should we stay in SDI at this moment in time? And then questions about automation and what IP brings to the table and things like that. So first off, sort of the basic idea begins with this very simple thing that we've depended upon for 15 years: serial digital interface, bulletproof, straightforward, HDI out, or beginning with SD out, SD in, HD in, out. Very simple serial digital signals moving around the appliance that is in the core. Very, very straightforward. Cameras, switchers, multi-viewers, servers, and things like that. So the challenge then is how can we take advantage of the opportunities and the features that IP offers as we begin to need to do things like distance the subsystems and work through things like format changes as we begin to see deliverables that may turn into from HD to 4K, UHD, include HDR, higher frame rate for slow-mo, wide color gamut, those sorts of things. We need a more flexible system in the middle. So we'll talk about sort of how those things find their way into a core that is no longer that SDI appliance. And I think now at this time, 2020, we're sort of out of the early adopter phase, the sort of the really more difficult pioneering phase. And from Sony's side, we've been participating in a number of systems worldwide. And North America, frankly, sort of a little bit slower to come along. But if we look back over the last couple of years, beginning with OB trucks, because that's a nice place to start, a nice self-contained environment, but now into larger facilities across the world, these systems are in place and supported by the standards are going into service. And a lot of lessons learned as we start to build around the standards that govern all this. So when we look to how we're going to connect these things together, then there's a family of standards and recommended practices and reference architectures that govern this, because customers and end users and integrators and engineers need and want to and are entitled to build those best of breed systems. So just like we can make decisions about cameras and switchers and displays and servers and things like that, knowing that they all can integrate in SDI, we need to be able to do that in IP. So a family of standards comes together, and it's worth sort of reviewing, just because things that will come up as you begin to evaluate and put together the pieces. So fundamentally, I think most of us have come to know the SMPTE family of 2110 specs. It's the kind of a thing you don't need to memorize or spend a ton of time on, except to recognize you'll hear in conversation as you explore these things and put them together, a couple of things. If we think about what is in SDI, primarily it's video streams, audio tracks, and ancillary data like closed captioning or SCSI triggers and things like that. So you may hear in conversation under 2110 characteristics and features like -30 audio, -40 captioning and ancillary data, -20 video, and those are just sort of nuts and bolts fundamentals. The other important thing is you'll begin to be aware of the new thing that genlocks everything. We still have, because we're evolving, we still have black burst and tri-level sync. But now that we have an IP router in the core of this thing, this new clock called PTP, Precision Time Protocol, that's the governing thing that's going to let us gen lock everything. So we'll explore that a little bit, but those are a couple of top level things to be going forward. Now, the other thing that enters the conversation pretty quickly is NMOS. So if you're not familiar with this term, this set of specification and recommendations governs sort of what the software management layers are going to need to be doing over IP. And fundamentally now, and they share a characteristic in both with the SMPTE standards, that you'll notice they're not particularly old. So we're still in version 1 point something in these specs. And so they iterate and they get adopted and updated over time. But again, we're sort of out of the heavy lift early pioneering days. So within NMOS, that part of the conversation leans on two areas right now, with more growing. You'll hear discussion of ISO 4 and ISO 5. So that fundamentally says, in anything we put together, we need a governing platform that's going to reach in and give us two simple things. Sort of the equivalent of plug and play. That's the device discovery and registration that says we're going to plug in stuff into our network and we need to keep track of it. And it needs to respond just like if we have a laptop and we plug in a keyboard or a webcam or something. We need this system to understand what's plugged in and present it to the user. So device discovery, and then second, connection management, meaning we need to do the simple things that we do today in SDI. A source signal needs to find a destination port. A camera needs to find a switcher input. Simple cross-point routing. And so while under the hood, that's now much more complicated than SDI, this is part of the conversation in terms of compatibility and interoperability. Now, many people on this call may not know what this next phrase means, but once upon a time, there was this thing called the Good Housekeeping Seal of Approval. And it meant that a magazine might take a vacuum cleaner and test it and put a stamp on it that says, this is a good vacuum cleaner, it's UL tested and all that. We fortunately have something similar today. The JTNM organization is an organization that lets vendors like us do testing and interoperability and compatibility tests together. And if you pass those tests, then you get the JTNM stamp of approval. And we have this across the IP Live product line. It's very important to us, again, to sort of support that idea that we're going to create compatible, interoperable systems. And that's one thing to look for going forward. So with these standards in mind, this is a snapshot from the family album of a system about 2 years on the air. We have to keep in mind as vendors and designers and builders that the first job is that this shall not be super disruptive to the people that work in it. So operationally, we're going to do all this change, which is profound infrastructure change, but this is all under the hood. The people that step up to cameras and vision mixers and RCP panels pretty much should not know that anything is different under the hood. So a lot of work to make this feel natural to operators, because change can be super painful in workflows. So number one, this is going to slip in under the hood. We keep that in mind. And then if we do it correctly, then we get to delight our end users by responding to their needs, meaning flexible formats, quick changes, resource sharing, a bunch of new things in the system can kind of come to bear and then present enhancements to the broadcast and workflow chain. So this is just one example, and indeed it's an example of best of breed multi-vendor solution coming into a large scale operation completely in IP. And then it's part of the heavy lifting. We do recognize that it's now pretty easy to just count up sources and destinations and figure out that we need a 256 squared router, we need a 1024 router, or whatever. There's some work and some creative design in the networks that sort of fuel these things and support these things. We have a lot of experience on this on Sony side. Diversified has done a number of systems on their side. And so we're sort of out of the early stages, and we can now confidently put these things together. So I mentioned a couple marquee systems that you may come to know, and I think this one for Time Warner has now been in service a year and a half, I think. A similar sort of thing. It was built to take advantage of the flexibility of IP systems, a lot of learning, a lot of multi-vendor collaboration came together. And that is an operation now doing what it does in Manhattan. And if we do put these things together, a standards-based set of components, then we get toward this nicely elegant engineering solution. And under the hood, then, instead of many coax cables, we have a smaller number of Ethernet cables delivering these high-speed clock-dependent signals very flexibly across networks. And so away we go. So looking in then, if we have this layer of IP and we have this family of different kinds of systems that we need to connect to it, then we'll talk about what supports all that. And a couple of layers of orchestration, of harnessing this IP flexibility. Fundamentally, all systems must have a broadcast controller. That's that job of NMOS, ISO 4, ISO 5, that must connect into the routing fabric, complete the job of keeping track of what's plugged in here, there, and everywhere across the network dynamically as it changes, and then delivering to the user that mechanism, both in hard panels and soft panels, for doing what they're used to. Source, destination, take, the nuts and bolts of the infrastructure. And then once that's in place, the next major function that steps in is this notion of device orchestration. So we're going to walk through a couple of different things here in a minute, but you end up with all of the subsystems and just tons of devices that are very software centric. Like, it's very common now to everything in the plant used to be serial connection to drive it or a dedicated app. Most things now have a web page for setup and configuration and changing settings and virtualizing UIs and things like that. So you end up with many devices that need to be managed in terms of configuration to make them all work together to do what you need them to do. Before the show, you set up different things for presets, for cameras, for switchers, for whatever. During shows, then you need those monitoring tools. So this layer also interacts with the devices to give you that visibility into what the systems are doing, because we need to troubleshoot often hiccups and things that come up in our system. So if we look at sort of start to step down this path of how things connect, in the have our IP switch, stack of plain vanilla, Ethernet ports, just the most straightforward thing that we've seen, like in every equipment closet and every IT room on the planet. Now we're going to depend upon this to build up our network for high-speed clock-dependent things in our production system. So looking at cameras and CCUs first, then how do we get our camera chains into this fabric, this network arena? We make a lot of cameras for different applications. We have small, medium, and large CCUs. So very simple for camera chains is we introduce an option board right alongside all our traditional SDI analog or SDI video and audio ports, and that introduces the IO for 2110. So these might typically be 25 gig Ethernet fiber pairs. And we have 2 in everything for redundancy, because on critical systems, we may make a design choice that we want to have this camera chain have a redundant path for backup and resiliency and things like that. And yep, we have our good housekeeping seal of approval on all these things. Away we go. Important also to recognize that now that we've super simplified the cabling to a degree, each one of these Ethernet, these fiber pair Ethernet connection points are handling a lot of signals. You may have 4K primary program coming out of a camera head, HD coming out of a camera head, return video going to the camera head, audio tracks from the camera head, intercom going to the camera head, and very importantly, in the middle, here's our PTP. In CCUs, we have the choice of either locking on Blackburst or locking on PTP. Many systems will then move to requiring PTP clocks, so that's our Genlock signal. We also, because our reference architecture sort of guides us to separate a media LAN with media signals from a management LAN, we have often then another segment which carries tally information, sort of lower speed things, SNMP traps and things like that. So behind this very elegant streamlined cabling is a lot of different signals going on. So here's another view of that. We might today have a studio camera with this big, thick, SMPTE hybrid fiber coax, fiber, copper for power, a bunch of things going to a CCU, carrying that today. And then out of the CCU, we have this nice, efficient IP encapsulated bundle so that we can exercise what networks do, what switches do, and deliver that signal across a LAN to a 2110 production system, or deliver it to multiple points anywhere that our networks can reach. And that's a pretty compelling feature. We can also then, for example, if we've needed to technically distance our camera shading people, we can put them at a different place on the network and give them access to the video streams and the control paths back to this camera in order for them to do their job. So camera into CCU into 2110. There's also some very new sort of innovation for last year to take that a step further. So we have this throwdown box now called the Camera Extension TX30. And that is to say that at the camera position, we may not need full CCUs. Think about an arena or a stadium. If we can efficiently have a throwdown box that translates this full portfolio of signals from the SMPTE hybrid fiber coax cable into that IP stream, then we've got a nicely efficient way to take advantage of networks, traditional IT networks, as long as they understand the Genlock clock that we're putting across it, and do the same thing. We may not need full CCU in the studio part or in the camera position. So another way, another thing that we can do is extend that. We call it, we trunk in a signal from a POV camera, taking advantage of that sort of embedding and sneaking across the network to drive a POV camera, for example. So you begin to have these signals on networks that have more flexibility. And up till now, everything that I've described assumes regular production, uncompressed video, high bandwidth stuff. Occasionally, when those segments need to go across a WAN to talk to media partners, to go across a campus from an arena to a control facility or something like that, you may need to or want to introduce some compression into that. And we have options for low latency compression, JPEG XS, JPEG 2000. And that's part of what we do with the appliances now that are part of the Sony family in the Nevion family, Virtuoso. So we can integrate into our IP system those segments where we need to or want to have compressed signals. So this is just a glance at the back of this throwdown box. Kind of mostly looks like a CCU, but now we're introducing this IP nature. And again, it sort of then is in that conversation of NMOS and compatibility and interoperability that we have to adhere to. Now, in a transitionary phase, we may have situations where cameras just need to be extended to take advantage of the network, but need to then sort of do the inverse, pull those 2110 signals off, recreate that SMPTE cable to feed existing CCUs. Or you may have I/O that is in place and needs to be in place for some time forward. We can then support 2110 as well as legacy signals going forward. So that's how sort of cameras and camera chains enter this equation. And next up, switchers. So what do we do to have the switchers, to have a small number of Ethernet connections now carrying everything that it did before? Same sort of thing in the switcher line. In the switcher line, you make decisions about what kind of inputs and outputs need to appear at the switcher. And we have boards that slot in, and they can slot in right next to 3G and 12G SDI if it needs to. Sometimes the designs call for that. But now we introduce, and these are typically 100 gigabit Ethernet pairs. And that's how, because there's a lot more signals going into and out of this switcher, but we slot in these input cards, and now we've got a switcher in the mix in our environment right alongside everything else. And at the same time, now that we've built up this idea of networking signals around wherever our network can reach, we introduced the idea of resource sharing in many, many parts of the product line. And you can then begin to do things like carve up hard assets like a switcher, many inputs, many DMEs, many characteristics, into logical devices. So it's very flexible and useful to be able to say, maybe in one day part, I've got a control room and a studio, and I need 3 DME and 18 patches and whatever, and I need that show to be in HD. At the same time, I need a control room and a studio to boot into UHD. And I need a different set of assets attached to it. So we begin to start to expand the idea of resource sharing by doing clever things like that with switcher lineup. And then for things like replay servers, which we very often have either for simple segment playback or for slow-mo and things like that, that device then has to enter the network fabric, but it also has the characteristic that it may be hooked up to high frame rate cameras, higher bandwidth requirement sources. It may also have direct SDI things still, depending upon the design. But in this case, we have a set of 4 25 gig Ethernet connections mirrored in a redundant side, but that gives us the flexibility to do high frame rate, to do what we need to do in a replay server, so it can sort of join the party and do its job in this new IP infrastructure. So then it's important also, as we build this up and grow into IP, that there is for a long time going to be many SDI things at the edge. And we'll need to bridge that path to SDI for a long time. Things like gateways will be on the radar. IP on the main core fabric, and then bi-directional simple SDI signals, and up to and including 12 gig SDI as well, to do things like up and down conversion at the edge, handle HDR, manipulate, do some signal processing, but sort of edge appliances in the mix of things. Okay, so that's sort of the fundamental building blocks of like a lot of what might be then now plugged into our switch. But if we just plug them into our switch, nothing happens. There's no smarts in that until we introduce this broadcast controller. In the SDI world, we had this appliance here, and it had applications, and right away you can do cross points and things like that. But we depend now upon this layer called the broadcast controller. We snap in a host server and a backup server because this is a really, really important component. And once that's in, it goes about doing its job of saying, what's plugged in, what are the characteristics of what's plugged in, and how do I move signals around? It presents it to the user in a UI, a very highly configurable UI, to say, camera 1, destination 2, take. And this is sort of becomes that simple router controller because we have to do it and we need to do it. That's part of the role of the broadcast controller. The other thing too is that our documentation and our system maps, what's connected to what, where is the signal going from, say, a camera to a VDA to a router to a monitor. Those things look very different in IP. And we're used to sort of plopping in a cloud and just going, yeah, it's networked in this side and it's available at this side if we can find its IP. We need different visualizations to understand what's connected where, what the status is, what's in Genlock, out of Genlock, hopefully not. And we need those tools. And then over time, as we plug in more things, part of the lifecycle management for IP is to have those tools, like are in the broadcast controller, to help us map what's connected where, what systems are healthy and happy, and what systems might need some attention. So that's all part of the broadcast controller doing its job. Important to know that not everyone likes to or wants to work on UIs. So the broadcast controller also gets connected to hard panels. So many operators, it's simpler and more repeatable for them to do what they've always done. Source, destination, take, and then you put these panels all around the system. They talk very nicely to the system controller under the hood. Again, we've sort of presented and maintained an operational style that helps the transition for the operational staff. Part of the operational staff, or part of the staff rather, are the technicians and engineers that need to maintain it. So another thing that the broadcast controller does, for example, if we have a design network, part of the design is your clocks, like we've always had black burst and tri-level sync and GPS antennas. Part of that design needs to be reflected because it's very different. We don't have patch points anymore in IP. So we need more tools then to understand Genlock. Green light's good, red light's a problem. And to understand this clock, which is now much more complicated than 1 volt peak to peak black burst thing that's distributed about the plant. So those sort of tools happen as well. So once we've established that, we've got things plugged into a central core, we've got a broadcast controller doing the basics. The next level is that level that says, now I've got to manage a whole bunch of software-driven things. That leads you to device orchestration. Plug in a server, plug in a backup server, and then it's tuned to understand your system and visualize what's happening dynamically. What RCP is a camera connected to at a given moment? What CCU is employed? Alerting, we receive alerts from equipment and we can visualize that to the technicians and the EIC, the people that have to maintain it. And we can then drill down into those things. And that's very different than, hey, there's a problem. Let me log into this thing, then this thing, then this thing, and try to put some correlation to solve a problem. The live element orchestrator, the device orchestration, gives us that worldview of what's happening in our system as it goes. And that's super important to really making it in the life cycle of an IP system. Okay, so the device orchestration, and we've probably described this to many of you before. It's a combination of a product called Data Miner from Skyline, very famous for this sort of data-driven monitoring and visualizations, and the Sony parts, which are sort of the very intimate control expertise of the major subsystems, the switchers and monitors and cameras and things like that. So we integrate Sony pieces and third-party pieces and things like switchers through a driver model so that we can manage those things in terms of simple things like snapshot of configuration when we need that configuration for a particular production, recalling that and initiating that. And then doing things like scheduling resources, just like you may need to, well, back in the days of offices, schedule a conference room. We then start to share production components, and we need to schedule those so that we have the cameras and the switcher portions and the resource that we need for a particular show, and manage that against other shows and other resource requirements. And things, simple things like booking out resources because we have to do some maintenance or some software updates, because when you have this many software things, there will be many, many, many software update opportunities, which can be a scary thing in life cycle maintenance. So again, Leo, Live Element Orchestrator, device orchestration, gives us that visibility, alerts when things might attention, and also we can then begin to put those macros, those sort of groups of setups and salvos onto hard panels too, because it may be desirable in a design to have soft panels and hard panels as well. Orchestration, I mentioned, that's sort of scheduling and understanding those sorts of things. So then let's see. Come on, there we go. So all this sort of comes together so that we get to the point in this brave new landscape where we have our machine rooms attached to our IP switch fabric that reaches out all the places where we knit in what we need to connect to. And we can have shared resources that can be assigned to control rooms and studio spaces and media partners and things like that. We can orchestrate changes to say, today we have this combination, this afternoon we have a different combination. We go from HD to 4K, we go from a studio to a control room, to a different control room, to a remote. And those things like the device orchestration give us those tools. So that's all sort of a story about what we're doing in the plant and in the facility. So in that networking design can be satisfied in a number of different ways with off-the-shelf IT, very media-capable IT things. So one of the things that led us to the next step and sort of completing this idea end-to-end is addressing what happens in the facility, right? When we start to talk about production hubs supporting remote operations, or media partners supporting a sister station in a DR scenario or something like that. We have a broadcast controller layer. We talked about that. We have device orchestration within the facility. We talked about that. The thing that led us to the next step and the newest member of the family in Nebion is needing some expertise and some tools to exercise this beyond the facility. And by that, I mean, the illustrations that we looked at were sort of everything in the same building or adjacent. Sometimes that control room is in one facility. Resources might be in another facility, another location. Control room might be somewhere else, might be an arena or something like that. So part of what the Nebion addition does is gives us some monitoring control and orchestration, meaning sort of changing those segments, creating redundancies, responding to network congestion or things that may be out of our control. So we sort of brought Nebion into the family to fit right in there and take us from the IP facility in the traditional way that we've sort of started out the story with and extend it into the wider world. So we design networks like we've just sort of described, switchers and cameras and all those things. And then we have the opportunity to maximize as we traverse different networks. And it becomes a really important thing to control these, to manage network realities, to do things like creating redundant paths when you need them, and being very practical when you don't. And then managing those endpoints where you might need compression because they're lease lines or there are reasons why you need to muck signals and move them around. At the same time, we want to have visibility to those networks and our signals as they travel, because now we have the opportunity to not just hand off an SDI to a terminal piece and let it happen with a third party, but we can manage those things and keep an eye on our network, understand the topology, and manage that. So now, with that in mind, with the remaining time that we have here, then I'll invite Larry to find the mute button, or Carrie to find the mute button for Larry, and we'll talk about the sample system, because it was a customer that is the build out is happening now, and next spring it'll come to life. But it involved all these things, understanding the choice to go into IP and the requirements that that this customer expressed, and how we put the solution elements together. Larry?
Yep, I'm here. So I think in obviously there's great depths to be plumbed here in trying to understand the advantages of an IP system and all the components that that go into this. Clearly, nothing stands on its own. Everybody talks to each other. So that really emphasizes this idea of having a lot of project planning and goals identification for any IP-related project. You simply cannot just throw components at it. You have to understand the depths of the system and how everything interacts, and what you're trying to achieve. So this is, this is always a discussion with clients, but I think it goes to the next level when you're talking about an IP system. The nature of IP and 2022-7 offers tremendous flexibility and expandability and redundancy. So how much of that do you really want, and where do you want to go with it is also an important element to try to get out there. And then the issue of staffing. How can you configure the system to really make it easier for the staff to understand what's going on, provide the right tools for them to diagnose problems? How can you take advantage of automation to ease the workload? Again, all things that really kind of need to be determined right up front. And the supportability part of this, how is that orchestration layer going to help you monitor what's going on and fix these problems as they occur? So those are things that at a minimal level need to be discussed with clients about how they're going to envision the future of their systems and take advantage of the power of IP. So let's move on to the next one.
Sure. This is just sort of the walkthrough of, a customer deciding that it should be an IP core to give flexibility and to meet some specific requirements, then adding in that broadcast controller layer to drive everything, then adding in device control for lifecycle management and very efficient automation of everything in the plant. And in this particular case, they were news oriented. So newsrooms are, of course, highly automated now. So then we automate the in-show parts, teleprompters and lighting and newsroom rundowns and things like that. And then looking ahead with the right network orchestration, we can look ahead at, they had sort of described like, okay, this REMI thing is going to be really important to us. And we want to take advantage of sharing resources in our different offices. So with the right networking, you can then indeed have hard panels and soft panels for cameras and for switchers, and begin to drive shows from distant places in a really super flexible way.
So before we move on, I'll just point out a couple of things which are interesting here, in that when you talk about an IP core, the standards are set up for complete redundancy in IP cores if you so desire to have that. And the system takes advantage of the idea that everything is monitored, the health is checked continuously. If there's a problem in the IP core, you can switch to the redundant IP core, either totally or partially. So these are all very important in terms of critical operations and keeping your facility on the air. You can have none, some, or all redundancy depending on how you want to build your system. And again, here is a great example of a far-flung organization, London and Washington, D.C., and then eventually other places around the world and the country, where they all will talk to each other seamlessly, and every bit of it will know what every other bit is doing. So it's very exciting from the standpoint of the next level of technology.
Yeah, absolutely, absolutely. So that case study sort of wraps up what we've sort of described here. You know, some background standards, some basic plumbing of how we get to IP, some control platforms that are critical to this, and a sample case study. We'll prepare some links. We have a white paper on all these sort of topics that just came out in September, and we have a brochure that describes sort of the product side of the sample examples that I just went over. And I'll ask Carrie to sort of introduce the next steps, and away we go.
Excellent. Thank you so much. Really appreciate it, Steve, and appreciate the time today, and Larry, your time as well, and providing your insight. We did want to thank everybody for joining, and we do have a question that's come up in our Q&A, and invite you to submit those questions as you have them. But real briefly, before we get to the Q&A, I just wanted to remind everyone that we do have, this is one of 2 webinars we're doing with Sony. You can see that we'll be doing one next week, and the registration link is there. And I'll also send that through the chat window as well, so that you might have an opportunity to join us again next week or pass this along to your colleagues. So with that, I did want to thank everybody again. Please submit your questions as we are here to answer those. And we do have one question that has come in, and this one was expressing that they were recently on an IP truck with a Lavo router, I should say, and experienced some reference issues with cameras would power down to relocate. So they're looking at when the camera powered down, they would see some issues, and they wanted to look at how with their multi-view monitor wall, and let's see, it says here, with our multi-view wall in production due to the reference hiccup. So they're just looking at some answers to some questions there. I think you can see that probably in your Q&A.
Yeah, that's probably PTP and Genlock and timing has probably been the area of most joy and headache at the same time. Like the timing parts of this can be super hard to correlate. That's why you need those tools in there to begin to track those sorts of things down. Primarily, we lean on the broadcast controller to manage those things, but there's another layer of clocks. In any given installation, we have perhaps a GPS antenna, a source of timing, and then every one of the IP routers, and not so many switches, but the IP routers that touches that signal needs to be understood and architected in the correct way, depending on the design for that clock. So we have what we call boundary clocks, and tracking that timing signal from source to a particular destination is a task, is a troubleshooting challenge. So I don't know in that particular case if they found an answer quickly, but it can be super difficult. And so if you're an EIC or a technician or an engineer, then it's important as you look at these things, particularly in the timing side, to have that, understand that suite of tools to track down those things. We can't kind of put a scope on it as easily, but we can scrape data from an Ethernet port, for example, or if you have instrumentation like the Prism from Telestream, they have tools built in as well. Along with visualizations, what you might find in the broadcast controller, that engineering care and feeding effort is a task, and that's part of why the tool set is super, super important.
I would just add also, Steve, that the whole issue of configuration in an IP system is absolutely critical. It's not like SDI where you just basically hook up the components and hook up your reference and it all goes. You really need to get the configurations, the addresses, the timing all perfect. It'll be great when it's set up, but there's a lot more things to set up. And in a case like this with the truck, where the orchestration system, which in this case was Lavo, was initially configured, it's simply an unknown as to how the various cameras and multi-viewer and so forth were configured to interact. So these are the keys to having some experience in putting this together, so that you understand what those interactions are going to be, and you can sort of short circuit the problems right up front.
Yeah, yes, indeed. And that probably kind of points to, we sort of said that, we simplify it to present it to the user, but under the hood, that simple idea of keeping track of what's on the network, like a camera CCU and a switcher destination, that's actually a pretty intense database thing under the hood. That's not plug in once, I got it, I make an entry in the database. That's a heartbeat going like, I'm going to make sure this device is still there. And they have a little bundle of information that describes the characteristics of that device. And when you make changes, that gets updated. So there's a lot of sort of software development under the hood there that you have to sort of then unpack. That developmental dialogue just has to be worked through. That sort of points back to that first idea, that the standards that help you there are still pretty young standards. To be on version 1.x means there are some gray areas that get uncovered, but we have the tool sets to sort of, patch where we need to patch and answer those questions. So it's a challenge, but the tool set is ready to do that, and we'll get better over time.
Excellent. Thank you for jumping in to answer that question, and we appreciate the submission. And it looks like we are at the end of our session. Again, I just wanted to thank everybody for jumping in today. Thanks Sony especially, and Larry for joining us. I have provided their emails in the chat window if you do want to jot those down. If you have any further questions after today, please let us know. We will be providing a link to the recording from today so that you can pass that along again to your colleagues. And again, we hope to see you next week or to hear from you if you have any additional needs or questions that we can help answer. Thank you, Steve. Thank you, Larry.
Thank you.
It's our pleasure.
All right. Have a wonderful day, everyone.
Thanks, everyone.